Next topic in the polynomial is the operation with polynomials. Means just like we apply operations of addition, subtraction, multiplication and division between any two numbers, similarly we will apply some operations with the polynomials. So first operation is addition. In case of addition, we need to keep in mind that only like terms will be added to the like terms. And just like I give you an analogy, that just like we can add apples to the apples only, we cannot add apple with the banana, right? Because two apples are, you can say, they fall under one category of a fruit, means they are like, in the sense that they fall under one category of the fruit, right? Similarly, x square could be added to x square only. You cannot add x square with just x, or you cannot add x raised to power 4 to x square or x cube. X raised to power 4 will be added to x raised to power 4 only, right? So these are like terms, right? So in this example, as you can see, that 5x raised to power 4 can be added to 7x raised to power 4 only, because these two are like terms. So like terms are those terms which are having same order, okay? So same order term will be added with the same order. Now how we will add this, that we write one polynomial. Let us say I'm writing 5x raised to power 4 first, minus 3x raised to power cube minus 2x, okay? And just below this polynomial, I will write the other polynomial in the way that like term will fall under the like terms. So 7x raised to power 4 should lie just below 5x raised to power 4, just to make them look, you can say, easier how to add these two, just to identify the like terms. So if you can identify like term just by looking at this, you can straight away add any two polynomials, okay? So next term is 5x cube, so I will write below 3x cube 5x cube. Next term is 3x square. As there is no term in the above you can say first polynomial having x square, so I should write this 2x by leaving one gap for the 3x square. So 3x square here, then comes the x term. So here in the first polynomial we have x term as minus 2x. As there is no x term in the second polynomial, so we'll leave a gap and we'll just write the last term, which is minus 2, right? Now we have to add these two, right? So how we add polynomial, we just add the coefficient. For example, if I say you have to add 5 apples to 7 apples, total apples you will get 12 apples. So it is just like 7x4 plus 5x4 is 12x4, right? 5 minus 3 is plus 2x cube. There is no term in x square. Here there is no term. So I will write just 3x square minus 2x and minus 2, right? It's very, very simple. So this is how we add any two polynomials. Next is, let us see what happens when we multiply two polynomials, right? So it says that order of the product of two polynomials is the sum of the orders of the two polynomials. That means, for example, there is a polynomial x and I am multiplying this by x plus 2. So you will see that according to the algebra distributive law property, this will be x square plus 2x, right? So individual order first polynomial was 1, of second polynomial was also 1, but in the result after multiplication the order comes out to be 2. So orders get added. This is the meaning of this, the sum of orders of the individual polynomials what you are multiplying, right? So we just have to multiply each term with each term of the second polynomial. That means in case of multiplication there are no like terms rule that as we have in addition or subtraction, okay? Each term, whether it is like or unlike, will be multiplied by each term of the second polynomial. So just write this, that x cube will be multiplied by x square minus 2x minus 4, then plus 3x again will be multiplied by this minus 4, and lastly minus 2 will be multiplied by x square minus 2x minus 4. Let us quickly calculate this. x cube when multiplied by x square, according to basic law of indices, that if bases are same, powers get added. Okay, so x raised to power 5 minus 2x raised to power 4 minus 4x cube plus 3x cube, this multiplication, minus 6x square minus 4 into 3 is 12x, and lastly minus 2x square plus 4x plus 8. Okay, now we need to simplify this. We won't leave the answer here only. We need to simplify by looking as there is some addition and subtraction of some terms. So let us just verify whether there are some like terms or not. And if we are able to find out two like terms, we can add or subtract whatever is the sign of the coefficients. Okay, so let us see that this x raised to power 5, there is no other term which is having x raised to power 5. So I will write this x raised to power 5 as it is. Then let us see for x raised to power 4. No, so minus 2x raised to power 4 also as it is. Then we can see that this minus 4x cube and there is 3x cube. Okay, so this cube and cube can be added. One is minus, one is plus, so result will be just minus x cube, minus 4 plus 3. Then there is minus 6x square and minus 2x square, so total x square comes up to be minus 8. And lastly, we have this x term which is minus 8x plus some constant 8, this 8. Okay, so this is how we multiply two polynomials. I think it is very easy. It is just extension of distributive law of multiplication. Okay, next is division. I give you one example, then we will see what it is written. If I say, let us say you have a number 32 and I am dividing this 32 with 3. I will have a quotient which is 3. 3 into 3, 10 is 30, and I will have 2 as the remainder. Okay, I can write this 32 now as that this 32 is a multiplication of two numbers. One is your 3, which is called divisor. Other is your quotient, which is 10, plus this remainder 2. So 32 is divisor into quotient, which is 3 into 10, plus 2, plus remainder. Okay, the same identity we can apply, the same process we can apply if we have to divide two polynomials, right? This same property holds for polynomials also, but in this case we have polynomials, not the numbers. So we have that when a polynomial px is divided by another polynomial, which is your divisor polynomial dx, we get a quotient polynomial and the remainder polynomial. These polynomials may be constant also, depending upon the order. Okay, as we have already discussed that a constant is also can also be regarded as a polynomial. So your original polynomial px can be written as multiplication of divisor into quotient plus remainder. This x only indicates that these are now polynomials, not just numbers, right? Now, two important things we have to keep in mind, that order of the remainder must be less than order of the divisor. Just like we always have remainder less than divisor. If the remainder is greater than divisor, we can again divide the remainder. Same case applies to the polynomials, but now we will talk in terms of order. That if order of the remainder is less than order of divisor, then division process stops. If order is greater, then we can again divide the remainder with the divisor. So one thing is this, that order of remainder must be less than divisor, and second is that resultant order of px is a multiplication of divisor and quotient, so their order will be the addition of the order of divisor and quotient, because this divisor and quotient, they are multiplying to each other. So this resultant order will be addition of these two orders, just like we have done in the previous example, that highest order of the resultant will be addition of the order of the two individual polynomials. Because in this case, as you can see, if we see the previous slide, that this highest order is 5. So here in the first polynomial, order was 3. In the second, it was 2. Right? So in the resultant, it comes out to be 5. So this is saying the same thing. Okay.